Hello, welcome back to my channel. For main content, you can directly jump to this particular timestamp. Before I continue, I wanted to tell you that I have mentioned only those tools in this roadmap that are commonly as well as widely used as standards. There are other tools exist in their specific category, which I will mention later in this video. Also, this video might get long as I will be explaining each and every topic I mentioned in this roadmap. So the first thing is to learn a programming language. It doesn't matter what language you pick, but it is important to learn at least one. You will be able to use that language to write automation script. For example, you can learn about Ruby, Python, JavaScript, Go or Rust. Once you are done with learning a particular language, then you should know about different OS concepts, at least understand those concepts. I have mentioned only those specific concepts that I think and I feel is necessary. Even I had to start, I would start with these ones. There are other ones, but I have mentioned only these ones. For example, it's good to know about POSIX, networking, process, sockets, service management, startup management, threads and concurrency, IO management, file system, memory storage, virtualizations. So what is POSIX? POSIX is Portable Operating System Interface. It's a family of standards for maintaining compatibility between operating systems. And what is networking? Networking refers to interconnected computing device that can exchange data and share resources with each other. Okay, and then we have process. So processes means program in execution. It generally takes an input, process it, and then gives us an appropriate output. For example, PS, right? So it takes and then gives an output. It could be used in Linux to get all the list of processes that are running in the foreground. So this is what it means. Okay, then you have sockets. Sockets is an endpoint of a two-way communication link between two different processes on the network. It could be same or different machines. And then you have IO management. Okay, IO management is one of the important jobs of an operating system, is to manage various IO devices, input output devices, including like mouse, keyboards, touchpad, disk drives, display adapters, USB devices, LED, and it just goes on. Okay, then you have file systems. A file is named collection of related information recorded on a like secondary storage such as magnetic disk, like, or magnetic tape, or SSD, hard drives and optical tapes. Generally, a file is a sequence of bits, bytes, lines or records whose meaning is to defined by file creator or the user. Then you have memory or the storage. Then virtualization. Virtualization is the creation of a virtual rather than actual version of something, such as like creating an operating system, a server or a storage device or network resources. It uses any software that simulates the hardware functionality and recreates that virtual system. Okay, then you have service management. Service management is systemd. You have probably heard, or like if you already use Linux, you always know that there's a thing called command like systemd. It's a system management daemon which replaces the sysv init process to become the first process with PYD, which is PYD1. Then it gets executed. Okay, and now it is being used as like replacement of initd to overcome all the shortcomings of it. Like it uses systemctl command to perform all these things. Then you have startup management. Startup management is init.d. You have already used that if you are already using Linux. And then you have threads and concurrency. Threads are an active entity which executes a part of a process. It is a sequential flow of tasks within a process. Once you gather a good understanding about different OS concepts, you should go and learn about how to manage servers. For example, here you can see you need to gain administration knowledge and learn Linux. If you are already not using Linux or you don't have any idea about that, then you need to make yourself comfortable with any distro. And if you're very beginner with Linux, I would suggest going with Ubuntu. In managing servers, you need to have understanding about network tools. For example, traceroute, MTR, ping, nmap, netstat, UF firewall, TCP dump, IP tables, and it just goes on. Okay, these are the ones you should have a good understanding. Not exactly very expert level, but having a good understanding about these will get you far away. Then you need to learn about operating systems like Windows. That's a crap thing. I would never suggest that. but that's there. Then it should be good if you learn about FreeBSD, OpenBSD, NetBSD, or Ubuntu or Debian, any of these. Okay, but generally there are like Ubuntu, Debian, then Arch, then there are other ones like Pop OS. You can learn about those operating systems. Those gives you good experience and exposure. Okay, and because most of the servers that runs Ubuntu, so it's practical to use Ubuntu as well. Then you need to learn terminal and be very good at it and know all the commands that comes under terminal. For example, it's good to learn about Tmax, Vim, Nano, Emacs, then Bash, shell scripting, because most of the time, even if you're just doing DevOps work, most of the time you might find yourself writing bash scripting, shell scripting, for example, makefile, dockerfile, and there are other files. Then there are monitoring tools in your operating systems like htop, this one. Okay, this is where you can check all of your details that are running currently in your machine. Then once you learn how to manage a server, okay, the basic entry point is to learn about the operating system, Linux specifically, and then learn about the terminal and all the Linux related networking tools. Then you should feel confident that, okay, once you grasp these basic ideas, then you should be moving forward to the next one. Then you need to learn about networking and security protocols. For example, you have HTTPS, HTTP, SSH, FTP, SSL, TLS, and learning about OSI models. What is OSI model, by the way? Open System Interconnection means OSI is a conceptual model consists of 7 layers. Okay, that was proposed to standardize the communication between devices over the network. This is something that you need to understand. And then you have white, gray listing. White listing is a process of adding an email to an approved sender list. So emails from that sender are never moved to the spam folder. This tells an email server to move messages directly to their inbox. Okay, and gray listing is a method to protect email users against spam, and a mail transfer agent like MTA using gray listing will temporarily reject any email from a sender it does not recognize. So that's about white gray listing. Then you have port forwarding. Port forwarding, sometimes called as port mapping, it allows computers or services in private network to connect over the internet with other public or private computers or services, since firewall exists to keep unwanted visitors out, right? The visitors you want to get in are going to need a way to do so. Like knowing the IP address is not just enough. Request needs to be directed to that connected or the correct port as well, right? So that's about port forwarding. And obviously you also need to have an understanding about DNS, which is domain name system. You can get it as like a phone book of the internet. It knows a specific IP address, and using that IP which is internet protocol address, it finds and it redirects to that. So that's DNS. And then SSL, TLS, secure socket layer, which is SSL, and transport layer security, which is TLS, are like a cryptographic protocols. It is used to provide security in the internet communication, in short. Then once you gather the understanding about networking security protocol, you should know what a specific topic is and how to set up a topic. So what do I mean by that? For example, you need to have an understanding about web server. So what is a web server? What is a reverse proxy? What is a caching server? What is a forward proxy? What is a firewall? What is a load balancer? And then how to set up a reverse proxy, how to set up a caching server, how to set up a web server. So this is what I mean by this particular thing. And when you're dealing with DevOps, you need to set up a lot of pipelines, and in that pipeline you need to know how you route all the networks and all the details, all the data. How do you do that? So that's that. In that scenario, you need to have understanding about web servers. Web servers can be contained with multiple tools such as Nginx, Apache, Tomcat. So Nginx is the highly used. So Nginx is a powerful web server, and it uses a non-threaded, event-driven architecture that enables it to outperform Apache if configured correctly. So, but I have mentioned Apache because many people also use Apache, and it can also do other important things such as load balancing, and HTTP caching, which I mentioned over here, can be used as a reverse proxy. Then we have Tomcat, but if you only even learn about Nginx, you can pretty much go as far as you want. And then you have reverse proxy. Reverse proxy is a type of proxy server that typically sits behind the firewall in a private network and directs clients' requests to the appropriate backend server. And it provides an additional level of security by hiding the server and related details like IP address, to clients. It is also known as like server-side proxy. The common uses are like web acceleration, security, anonymity, and load balancing. Then you have caching server. Cache server is a dedicated network server or service acting as a server that saves web pages or other internet content locally by placing, previously requested information in a temporary storage. A cache server both speeds up access of data and reduces demand on enterprise bandwidth. For reverse proxy load balancing, you can also use Nginx that I mentioned. You can also use HA proxy, which is again a load balancer and a reverse proxy. And another one for load balancing, you can use Kafka. Then we have firewall. Firewall is a network security device that monitors and filters incoming and outgoing network traffic, like a barrier that sits between a private internet network and the public network. Then once you gather the experience or the knowledge about all these things, how to set up these proxies and servers, and then you should learn about infrastructure as code. And this is where the main part starts for DevOps. Like this is where you actually do the DevOpsing things. And by the way, DevOps is not a tool or something, it's just a practice. DevOps is a culture that companies these days adopts. Under ISC, you have things like infrastructure provisioning, containers, service mesh, GitOps, configuration management, container orchestration, and secret management. Mind you that these secret management, container, all these things, they have various tools, but I have only mentioned the ones that are commonly used, and people generally choose these ones. In infrastructure provisioning, you have things like Terraform, Pulumi, AWS CloudFormation. I'll come to this AWS CloudFormation later, but this Terraform Pulumi is like a tool. It can be used in many different cloud service provider APIs. You can use it to set up IAC in AWS, GCP, or any other things. Terraform focuses on immutable approach to infrastructure with a file like Terraform state file center to track the status of your real world infrastructure. Then you have Pulumi. Pulumi is again an open source infrastructure as code tool that you can write in TypeScript, JavaScript, Python, Go, .NET, Java, or even YAML to model the cloud infrastructure. So the difference here is that you have to, if you write like Terraform, you have to write it like .tf file, and if you use Pulumi, it's like you can use it pretty much any language. So that's most of the things. And then you have AWS CloudFormation. It's a AWS product again, and it not only just lets you model, it also helps you provision and manage AWS and its third-party resources by treating the infrastructure codes. And then you need to learn about containers. Like the main one is Docker, and pretty much anyone learns and know about Docker. So if you learning about IAC, the infrastructure as code, then you need to have a good understanding about Docker as well. Then there are things like service mesh. Service mesh is like a platform to control how the microservices works. So in there you have Istio and Consul. So Istio is like a mesh platform that provides you a way to control how your microservice architecture shares data within one another. It includes API that lets Istio integrate any logging platform such as telemetry or policy system. Then Consul also does the same thing, but it's just that on top of Pulumi, it requires a data plane and supports both proxy and native integration module. And Consul shapes with a simple built-in proxy so that everyone can work and everything just works out of the box, but also supports third-party proxy integration such as Envoy. Then you also need to have an understanding about secret management. Secret management, nothing but all the secrets that you have in your code, AWS related credentials or credentials that are coming through like logging, that are production credentials that you manage using secret management. And generally people use Vault for that. And then you have orchestration, container orchestration. So container orchestration can be done by Kubernetes and as well as Docker Swarm. Okay, Kubernetes is again a container management platform, and it is open source and the dominant product in this container orchestration. Using Kubernetes, teams can deploy images across multiple underlying hosts and define their desired availability, deployment logic, and scale logic in YAML files. Then you also need to learn about configuration management like Chef, Puppet, and Ansible. Ansible is an open source configuration management application deployment and provisioning tool that uses its declarative language in YAML file, and it's a agentless, meaning you only need remote connections via SSH or window remote management. But people generally choose SSH and barely anyone use like remote management from Windows, but you can obviously use that. And then GitOps, which is like Argo CD and Flux CD. So GitOps these days are getting very popular, like Flux CD and Argo CD. Argo CD is a continuous delivery tool for Kubernetes that is based on the GitOps methodology. I'll just make a video about that GitOps, but for now you can understand that it is used to automate the deployment and the management of cloud native applications by continuously synchronizing the desired application state with the actual application state in production environment. And in Argo CD workflow, changes to the application are made by committing code or configuration changes to a Git repository. So that's about this GitOps. Once you kind of learn and have a basic understanding or a good understanding about infrastructure as code, then you need to learn about some CI/CD tools. So in CI/CD tools, you have things like Circle CI, AWS Code Pipeline, Travis CI, GitLab CI, Jenkins, GitHub Actions. And if you already use GitHub, you probably know that GitHub Actions, but these are just like how you do your continuous integration and continuous development pipelines. This is a very broad topic, so I'll just leave it here, but I'll make a detailed video about each and every topic later on. Once learn about any of these, doesn't matter you have to learn about all, but I'll prefer GitHub Actions, Code Pipeline, CI/CD, Circle CI, and Travis CI, and Jenkins obviously. You can also try GitLab, but basically yeah, it's like almost all, but if I have to say one, then you can learn about GitHub Actions. Okay, start with at least GitHub Actions. Once you're done with learning about CI/CD, you should have an understanding, or at least go with learning about infrastructure monitoring. So there you have things like log management, infrastructure monitoring, application monitoring. And in infrastructure monitoring, you have things like Prometheus, Datadog, Grafana. So what is infrastructure monitoring? First of all, infrastructure monitoring is like a provisioning thing. So it provisions, checks your infrastructure in cloud. That includes like DNS, networking, security policy, servers, containers. Then you have application monitoring. In application monitoring, you have things like New Relic and OpenTelemetry. What is application monitoring? First of all, so it refers to a practice of making the status and performance of a given application visible. That might include details such as stack trace, error logs, and the line of code implicated in a given failure. For example, payment, okay, that the payment is not working. So it gives you a kind of sense that particularly in which section in your code base the problem is occurring. So you can just directly go and fix that. For that, mostly people use New Relic and OpenTelemetry. These are the standards, but there are others like App Dynamics, Istana, and Jagger. So New Relic is where all these development, operations, security, and business teams solve software performance with actually like real data. Same thing for OpenTelemetry also. You also need to learn about log management like Loki, Elasticstack, Splunk, Papertrail. I would suggest at least go with these two first, Elasticstack and Papertrail. But obviously you also need to learn about Loki, Splunk, because they also use these two. There are other ones actually, not just only these. Like there are one called Greylog. You can also learn about that. But these four are mainly used. So what is Elasticstack? It's a group of products. For example, Elasticsearch, Kibana, Beats, and Logstash. So Elasticsearch used to search an analytics engine. Kibana used as a dashboard to visualize your data. So that's about infrastructure monitoring and understanding. So these tools really help you to have a good understanding. Then at last you have cloud providers. Obviously you can learn it from the beginning or at the end, doesn't really matter. You just need to have understanding. AWS and Google Cloud, or any of these, doesn't matter. And if possible you learn both, but there are others like Alibaba, then Linode. You can also learn about those, but generally people these days uses either Azure, AWS, or Google Cloud. But even if you learn about AWS or Google Cloud, you're pretty much good to go. So that's all. I wanted to make it very simple, and like I'll share this in the description. You can check this out. So this is the roadmap. This is how it looks. Okay, the video is done. So this is how the roadmap. So first I'll just quickly tell you that first learn a language. Then learn about all the different OS concept. Then learn about how to manage servers. Gain administration knowledge. Learn Linux. Make yourself compatible inside terminal. Right, then learn about networking, security protocols. Then learn first know about what are the things like what is web server, reverse proxy, caching server, forward proxy, load balancer, firewall, and how do you set up all this. Then you learn about infrastructure as code, which is IAC. Here you need to have understanding about secret management, container orchestration, configuration management, infrastructure provisioning, containers, understanding about CI/CD pipelines like Circle CI, Code Pipeline, Travis CI, Jenkins. You learn about infrastructure monitoring tools like Loki, Splunk, then Prometheus, Keybase, Datadog, Grafana, New Relic, and then also you learn about AWS and Google Cloud. And if you get good at these things, then you pretty much can call yourself as a DevOps person. Okay, and by mind that DevOps itself is not a tool, it's a culture. That's pretty much it. You can also find this, and my main motive here is to simplify all these things. There are other things you will find on the internet, but this is kind of a general roadmap that you can follow and get started with all these things. Okay, so the video's end, I'll just talk about some other stuff. If you want to leave, you can leave. I'm planning actually that I should make videos about all this concept, and then like we have all these things, so like whatever I mentioned, I should make videos. So do let me know if you are interested to watch those videos, then I will definitely make them. So that's pretty much it for this video. Do let me know what other things I failed to make you understand, and give me your feedback and let me know what other things you have in your mind. I'll definitely like read and try to improve. Thank you. Bye.